Hi everyone, so today we're going to be doing notes on section 5.5, which is all about long division of polynomials. I want you to go ahead and pause this video and do the warm-up problem on your own, and you are doing this without a calculator, so you're doing long division. And then when you're ready to check your answer, push play. All right, everybody, go ahead and check your answer really quick. Now I want to point out, I left this as a 1 down here. I did not add a decimal on and add a 0 and then continue to bring that down. So this is the exact same process we're going to use for dividing polynomials when we have the x's and then pluses or minuses added in instead of just a number. So I want to go ahead and label what these different parts are called. So the 8, the number that goes out here, whatever we're dividing in to the other number, this is called a divisor. The number that goes underneath, so in this case, the 2513, this one is called a dividend. This number that's up here at the top, for ours, it's 314. This is called your quotient. And then this number that's down here that's left over is our remainder. So when we write this without the decimal places, it would just be our answer that's up here, 314. And then what's left over is we have a remainder of 1, and we write that divided by 8. So when you write out your answer, it's the quotient. And then what you write after it is your remainder divided by your divisor, instead of writing it out as a decimal. So this is going to be the idea that we're going to be using for dividing polynomials, because we can't do anything with fractions or just adding on a decimal point for them. We're going to leave our answer when there is a remainder. We're going to leave it and write it as the remainder divided by the divisor. So let's go ahead and look at an example. We are going to be dividing polynomials. So we want to divide f of x equals all of this by this big polynomial. So we're going to set it up the exact same way we did with the warm-up problem, where we write this on the outside as the divisor, and then this underneath as the dividend. So let's go ahead and start to do that. Now for our divisor, that I'm going to leave a little bit of space so I have room. This, you just write it out exactly as is. Nothing changes. But for the dividend that goes underneath, you need to include any placeholders for missing terms in the dividend. So I have 3x to the 4th. I have an x to the 4th term. Oops, my line. I have an x cubed, but I'm missing an x squared term. So that's what I'm talking about with a placeholder. I'm going to add in 0x squared as my placeholder, and then I have the 4x minus 6. So I'm going to write a little note. Include any placeholders for missing terms in the dividend. Only the dividend. I'll underline placeholders also. And I'll explain why that's relevant in just a minute once we actually start going through this example. Now, when we did the division in the warm-up, that one, it's just one term that's out here in the divisor that you're looking at. Now we have multiple things. So when you are doing these problems, you are only looking at the first term. In this case, it's x squared. And we're going to look at that with the first term under here and ask ourselves, what do we multiply x squared by to get 3x to the fourth? Good. If you said 3x squared, you are correct. So we know we have to multiply it by 3 to make it have the 3 here. So x squared times 3 will give us 3x squared, but we want it to be x to the fourth. So I need to multiply it by another x squared. This is why we had to learn the exponent properties before this, because you need to understand that x squared times x squared becomes x to the fourth. Now what you do is you take this 3x squared and multiply it by this entire divisor. So 3x squared times x squared is 3x to the fourth. 3x squared times negative 3x is negative 9x cubed. 3x squared times 5 is positive 15x squared. This is why we have to have that placeholder, because it's going to make all of your stuff line up. Now in the warm-up, once you had that next term, you subtracted it from the line above. We're doing the exact same thing here. But I'm not just going to write minus out in front, because I'm subtracting this entire big polynomial. So if I subtract this entire thing, 3x to the fourth minus 3x to the fourth, those cancel out. That's our goal, is to make the first term cancel out. This next term will become a positive. Now, some people prefer to write it like this, how I did, where I just put the negative outside of parentheses. Some people like to go through and actually switch all the signs and rewrite this as minus, plus, minus. Whatever you prefer is fine. So negative 5x cubed plus 9x to the third becomes positive 4x cubed. 0x squared minus 15x squared is negative 15x squared. And then same as with regular long division, you bring down the next term. So now we're looking at our x squared and our new first term, 4x cubed. So what do we have to multiply x squared by to make it 4x cubed? Good. If you said 4x, you are correct, and it's positive 4x. Now I'm going to multiply this 4x by our entire divisor. So 4x times x squared is 4x cubed. 4x times negative 3x is negative 12x squared. 4x times 5 is positive 20x. And again, we are subtracting this entire thing. You can either write it like that or just go through and switch all your signs. So 4x cubed minus 4x cubed cancels out. Negative 15 plus 12 becomes negative 3x squared. Remember, when you add or subtract these, your exponents, that x squared term stays the same. This is like saying you have negative $15 and then you add $12 to it. Or you owe someone 15 apples, but then you give them positive 12 apples. So your x squareds stay the same. Then 4x minus 20x is negative 16x. And we have one last term that comes down. Arrow ended up being a little bit sideways, or a little crooked. Now we have a new first term. So what do we multiply x squared by to get negative 3x squared? Good. If you said negative 3, you are correct. So negative 3 times x squared is negative 3x squared. Negative 3 times negative 3x is positive 9x. Negative 3 times 5 is negative 15. And again, we are subtracting this whole thing. Negative 3x squared plus 3x squared, they will cancel out. Negative 16x minus 9x becomes negative 25x. And then negative 6 plus 15 becomes positive 9. Now, there is nothing we can multiply x squared by to make it negative 25x. So we are done, and what's left down here is our remainder. This is our remainder. This whole thing that's up here is our quotient. So when we write out this answer, we have our quotient. So 3x squared plus 4x minus 3. Now writing out this last part, it's our remainder divided by the divisor. Now I'm going to put, oops, I just realized that the answer's cut off. There we go. I'm going to put a plus, a big fraction. I'm going to fill in my divisor on the bottom. So the x squared minus 3x plus 5. And then my remainder on the top, negative 25x plus 9. Now the reason why I say write a plus here, because even though our remainder on the top is negative, it just gets really complicated and really easy to mess up your signs if you try to change this. So just leave it alone and leave it as a plus. So our remainder still gets written on the top, and our divisor still gets written on the bottom. So this whole big giant thing is our answer. Now this one looks pretty complicated, our answer, because it didn't go in evenly, so we have this big mess that we had to add to the end, but we're going to do some examples where it does go in evenly. Oh, and I'll also write here, this part, this was the quotient. So that's how you write your answer. Let's look at another example. So this one, I didn't write it out with words. I just wrote this big old polynomial divided by this polynomial. Now, first question I want to ask, my dividend, do I have any missing terms that I'll need to put placeholders in for? Good, you should have said no. We have an x cubed, x squared, x constant. We have no missing terms. So let's go ahead and write this out. I have my divisor, the x plus 4. And then I'm going to write out my whole dividend, the x cubed plus 6x squared plus 5x minus 12. I'm going to go through this one a little bit faster, but I'm still going to explain each step as I do it. Let me zoom this a little bit. I highly recommend that if you have trouble with this, go through and write out all the steps first, or like watch this through as I do it. Write everything out and then rewind and watch it through again, just listening to my directions as I point to stuff when you already have it all written down on your paper. All right, so first things first, I'm looking at my first term, the x, and my first term, x cubed. So to make x into x cubed, I have to multiply it by x squared. And then I'm going to multiply x squared by everything here. So x squared times x is x cubed. X squared times 4 is positive 4x squared. I'm going to subtract that whole thing. First terms will cancel out. 6 minus 4 is 2. X squared. Bring down my next term. Now I have a new first term. So x times what gives me 2x squared? Good, you should have said 2x. And now I multiply 2x by everything in the divisor. So 2x times x is 2x squared. 2x times 4 is 8x. And I'm going to subtract this whole thing. First terms cancel out. 5x minus 8x becomes negative 3x. And then I carry down my next term, which is the minus 12. And I have a new first term. So x times what gives me negative 3x? Good, you should have said negative 3. Negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. Now this is one of them where everything cancels. Or where everything goes in evenly, I should say. So my remainder is 0. So let's see, I'm going to do it up here so I have space. So if the remainder is 0, then our divisor, which is x plus 4, is a factor. And my my quotient, x squared plus 2x minus 3, is also a factor. So this is just another way of saying this whole big thing, this whole big dividend is equal to my divisor, x plus 4, times my quotient, x squared plus 2x minus 3, because it went in evenly. Now from here, what we need to do is factor it. So this guy over here, we know how to factor this. So using the big X, negative 3 goes in the top, 2 goes in the bottom. What two numbers multiply to get negative 3 and add to get 2? Good, if you said 3 and negative 1, you are correct. So the x plus 4 stays the same, but then this quotient gets rewritten as x plus 3 times x minus 1. So this whole thing is our divisor, or sorry, not our divisor, our dividend, the x cubed plus 6x squared plus 5x minus 12 factored. Fully factored, I should say. And this is a concept that's going to lead us into our next unit. We're going to look at long division today, what we're doing in the notes today. Tomorrow we're going to do, or not tomorrow, Wednesday, we're going to do something called synthetic division. And it's eventually going to lead us to this, being able to fully factor things. We're going to do one more example together. Now this is another way that these problems may be worded. So you're given a dividend and you're already told that x minus 5 is a factor. So what this tells us up front is that when we do this division, we should get a remainder of 0 because it's telling us it's already a factor. So let's go ahead and write this out, x minus 5. And then my dividend, I have no missing terms, so I do not need any placeholders. And I have my first terms. I want you to try filling in this first line on your own. So go ahead and push pause, and then when you're ready to check, push play. Go ahead and check, see if you got that first section right. Now we have a new first term, and I want you to go ahead, try again, fill in the next line. Go ahead and push pause. When you're ready to check, push play. Go ahead and check your next step. Now, I just realized I made a mistake when I wrote out this problem initially. This should be 20, not 21. So please change this to a 20, not 21, because we want it to eventually go in evenly. My mistake. Change that to a 20. Now this last step we'll go ahead and do together. So my new first term, x times 4, gives me 4x, so it'll be positive 4. And then I get 4x minus 20. So when I subtract that, everything cancels out, and I get 0. So this tells me it goes in evenly. So what I have now, let's see, I'm going to write it down here. I have my divisor, which is x minus 5, times my quotient, which is 3x squared plus 13x plus 4. Now, when I factor this, my big X, the top is a times c, so 3 times 4, which is 12. Bottom is b, which is 13. My two numbers will be 12 and 1. But I have an a value that is not 1, which means I need to divide both of these by the a. And this one simplifies to 4. If you don't understand that and need help, please ask me in class or set up office hours. It is review, so I'm not going to go into it in detail right now in the notes. So I'm going to write out these two final answers, or these two final factors, I should say. And that is my answer, fully factored. Again, the factoring I went through really quickly because it is all strictly review. If you still have questions about it, please let me know and we'll set up a separate time to go over it in more detail. Otherwise, that is the end of our notes, and have a good rest of your day.